Example 4. Solve each system of equations using Gauss-Jordan elimination. If there is not a unique solution, either state no solution or infinitely many solutions. In the case of infinitely many solutions, parameterize the solutions and give one particular solution. All right, in example A, here is our system of equations. We have 3 equations and 3 variables. Okay, so we have 3x plus 5y minus z equals -7. X plus y plus z is equal to -1. And 2x plus 11z is equal to 0. Okay, first thing you have to do is actually convert this system of equations into matrix form. Okay, so we're going to write down our initial augmented matrix. Okay, so it's going to be very similar to what you did if you had just 2 equations and 2 variables. You're just going to write down the numbers that you see, the variables go away. In the first equation, there is a 3 in front of x, a 5 in front of y, a -1 in front of z. Draw your vertical bar to represent the equal sign, and then you have a -7 on the other side of the equal sign. Okay, so there's your first equation, and that corresponds to the first row of the matrix. All right, for the second equation, we have a 1 in front of x, 1 in front of y, 1 in front of z, -1 on the other side of the equal sign. And then the last equation, 2 in front of x. Notice there is no y. Y is missing. So you absolutely have to put a 0 in place here, okay? There is a 0 in front of the y, okay? Anytime a variable is missing, you have to put a 0 as a placeholder or you will not get the problem right. Trust me, it will not work out correctly. All right, so 0 in front of y, 11 in front of z, 7 on the other side. Okay, so this is your first matrix, okay? And now we're going to start operating on this matrix. To operate on this matrix, we are going to use those same 3 row operations that we learned in section 4.2. Number 1, you are allowed to switch any 2 rows. Number 2, you are allowed to multiply any row or divide any row by a non-zero number. And then lastly, the third row operation, you are allowed to replace any row with its sum with a multiple of a different row. Okay, so we're doing the same kind of thing, just with a larger matrix now. Okay, again, this you're going to have a goal. Okay, just like you did when you had a smaller system, when you had 2 equations and 2 variables. Okay, your goal is going to be very similar. Okay, you're going to want to the left of the vertical bar, you're going to want to have the identity matrix, meaning you're going to want to have 1s on the main diagonal, okay, 0s above and below those, okay, so that's the identity matrix, okay, where you have 1s on the main diagonal and then 0s everywhere else, okay, and then you'll end up with numbers, okay, on the right side of the vertical line, okay. That is going to be your goal for these larger systems where you have 3 equations and 3 variables, okay. You want to perform the row operations until you get to this, okay. And again, we learn from the smaller systems, you may not be able to get there, okay, but you want to get as close to this as you can, okay. Now, I want you to realize, okay, this goal matrix, okay, it is a particular case of reduced row echelon form, okay? This is in reduced row echelon form, okay? Each of the 4 criteria for reduced row echelon form are met, okay? Each row consisting entirely of zeros is below any row having at least one non-zero element, okay? There is no row of zeros there, okay? The leftmost non-zero element in each row is 1. That is true, okay? All other elements in the column containing the leftmost one of a given row are zeros. That is true, okay? And the leftmost one in any row is to the right of the leftmost one in the row above. Again, true, okay? So this goal matrix is just a particular case of reduced row echelon form, okay? All right, so let's get started. Like I said, this is very, very, very similar to operating on a matrix where you had 2 equations and 2 variables. Okay, it's just larger now. You've got 3 equations and 3 variables. Okay, so now this is your goal matrix. Okay, use those same 3 row operations to get there. Okay, all right, so let's go back to our initial augmented matrix. Okay, we are going to start by working in the first column. Okay, and again, the process is still column by column, okay? We're going to start each column, okay? First thing we're going to do is secure the 1 on the main diagonal. And then once we do that, we use that 1 to zero out the rest of the column, okay? All right, so in column 1, the first thing I'm going to want to do is put the 1 on the principal diagonal there. So I'm going to want to change that 3 to a 1, okay? The easiest way to do that here is to switch 2 rows. Okay, I have a 1 right here. So if I switch row 1 and row 2, then that is going to give me the 1 in this position. Okay, so what I'm going to do, I'm going to write, remember, I like you indicating all your row operations. Okay, so over here, I'm going to come out to the side and I'm going to say, okay, to get to the next matrix, I am going to do row 1 and row 2. I'm going to switch those. Okay, so that's going to give me a brand new matrix. Okay, remember row 3 is not affected here, so it will stay the same. All right, and so then I'm just going to switch rows 1 and 2. Okay, so row 1 will become row 2 now. And then row 2 will become row 1. And now I have a 1 in this position, and that's what I wanted. Okay, all right, so we keep going. Okay, I'm still working in the first column. Okay, I've secured my 1 on the principal diagonal, so now I need to zero out the rest of the column. Okay, so now I need to change this 3 to a 0. Okay, so the easiest way to do that is, like we said when we had smaller systems, getting your zeros, that's the best way to do that is to use the third row operation. Okay, I am going to replace the second row by adding the second row to a multiple of another row. Okay, well, what we're going to do here, like I said, the reason you get the 1 on the principal diagonal first is to help you get the zeros in the rest of the column. Okay, so since the 1 for this column is in row 1, okay, that is the row we're going to multiply by. Okay, well, what are we going to multiply row 1 by? Well, what is going to cancel a positive 3? A negative 3. Okay, so this is the row operation we're going to do. Okay, we're going to take row 1 and multiply it by negative 3. That will put a negative 3 right here. And then when you add negative 3 back to positive 3, you will get a 0. Okay, so this is going to be your row operation. Okay, so I'm going to go ahead and write down the new matrix. Okay, we are changing row 2 only, so I'm going to go ahead and leave row 1 alone. And I'm going to leave row 3 alone. Those two are not changing. Okay, and so now I'm going to go out to the side and do the work to get the new row 2. Okay, so what I need to do is I need to multiply row 1 by negative 3. Okay, I highly recommend that you write out your work. You're less likely to make a mistake. Okay, so if we multiply row 1 by negative 3, we're going to get negative 3, negative 3, negative 3, positive 3. Add that back to the second row right here. Okay, that's going to be 3, 5, negative 1, negative 7. Okay, we're going to get 0, 2, negative 4, negative 4. Okay. All right, so that's your new second row. All right, so that is your third matrix in this whole series. Okay, you can see this is going to involve a lot of work. Okay. All right, so we are still in the first column. Okay, we have our 1 on our principal diagonal. We've zeroed out this element. Now we have to zero out this guy. Okay, all right, again, we're using the 1 in this column to help us get the 0. Okay, Zeros are mostly accomplished from the third row operation, okay? All right, so my next matrix, how am I going to get there? Well, okay, I want to make a change to the third row, okay? I need this element to be a 0, okay? So what we're going to do, since we're changing row 3 to do that third row operation, okay, we are going to add to row 3. What are we going to add? A multiple of another row, okay? Since our 1 on our principal diagonal for this column is in row 1, we are multiplying by row 1, okay? What do you multiply by? Well, I have a 2 here. What would make that go away? A -2, okay? So that is going to be your row operation. -2 times row 1 plus row 3 becomes row 3, okay? Reason being, if you took row 1 and you multiplied it by -2, that would put a -2 here, and then when you add it back to +2, you get a 0. Okay, so let's go ahead and do that. All right, so in my new matrix, okay, row 3 is changing, which means row 1 stays the same. So does row 2. Okay, only row 3 is changing. Okay, please change things one row at a time. Okay, if you try to do multiple rows at once, you probably will get, there's a lot of numbers here. Okay, you might get mixed up, and even one incorrect number in your matrix throws the whole thing off. Okay, so just do it one row at a time. Okay, all right, let's go out to the side and do the work here. Okay, we are going to do -2 times row 1. Okay, so that's going to give us -2, -2, -2, +2. Okay, we're going to add that back to the third row. Here's the third row that we're trying to change. Okay, so 2, 0, 11, 7. Okay, so add those numbers. We're going to get -2 plus 2 is 0. -2 plus 0 is -2. -2 plus 11 is +9. And then 2 plus 7 is 9. Okay, so there is your new third row. All right, so now we are done with the first column. Okay, we have a 1 on our principal diagonal. Okay, and then we have zeroed out the rest of the column. Okay, that tells us we can move on to column 2. Okay, so what are you going to change? Are you going to change the 1, the 2, or the -2 first? Okay, well, you need to secure your 1 on the principal diagonal first. Okay, your principal diagonal elements, okay, are 1, 2, and 9. Okay, so the principal diagonal element in this column is 2. We need to change this to a 1. Okay, so I'm going to go up here. Okay, we're going to move on up here, back to up here. Okay, so the best way to get a 1 in this position, okay, look at this second row. Remember, one of your row operations is that you are allowed to multiply or divide any row by a non-zero number, okay? Each one of these numbers is divisible by 2, okay? So we're going to take the second row and we're going to divide everything by +2 because 2 divided by 2 is going to give you the 1, okay? So we're going to come up here, okay, and our next row operation is going to be, I'm going to take row 2, I am going to divide it by 2, and that's going to become the new row 2. Okay, so I'm just transferring from my previous matrix. We are only changing row 2. Okay, so the first row and the third row are going to remain identical, so I'm just going to rewrite those up here. And then what I need to do is I need to take each of the rows, or I need to take the second row, each element in the second row here, okay, and divide it by 2, okay? So I'll do the work up here, or you can do it in your head. This one's not difficult to do. So my second row is 0, 2, -4, -4, okay? I need to divide each of those numbers by 2, okay? So 0 divided by 2 is going to be 0. 2 divided by 2 will give me 1. Okay, and then -4 divided by 2 is -2. -4 divided by 2 is -2. Okay, so here's your next matrix. Okay, all right, so we are still working in the second column. Okay. All right. You have secured the 1 on the principal diagonal. So now we need to zero out above and below. Okay. It doesn't matter if you change the 1 or the -2 first. Okay. I just usually go from top to bottom just out of habit. Okay. So I'm going to change the +1 first. Okay. Again, if you want to get a 0, you want to use the third row operation. Okay. So in the next matrix, we are going to want to make a change to row 1. Okay. To get there, we are going to add to row 1. Okay. What do we add? A multiple of another row. Okay. Which row do we multiply by? Well, the reason you just did this, you got your 1 on your principal diagonal, is to help you zero out the rest of the column. Okay. This 1 we just secured is in the second row. Okay, so we're going to end up multiplying by the second row here. Okay, what do you multiply by? Well, I have a 1 here that I'm trying to zero out. What would cancel out a 1? A -1. Okay, so we are going to multiply the second row by -1 and add it back to the first row. Okay, if you did that, think about it. Okay, if you do -1 times +1, that will put a -1 right here, and then you add it back to +1, you will get your 0. Okay, so that's going to be your row operation. All right, so your next matrix, we are changing row 1. So that means row 2 stays the same. Row 3 stays the same. Okay, so now I'm going to go out to the side and I'm going to do my work to get row 1. Okay, so we're going to take our second row and we're going to multiply it by -1. That is going to change the sign of everything. So we're going to get 0, -1, +2, +2, and then we're going to add it back to our row 1. Okay, so that's going to be 1, 1, 1, -1. Okay, so if we add, 0 plus 1 is 1, -1 plus 1 is 0, 2 plus 1 is 3, 2 minus 1, 2 plus -1, either way you think about it, that's going to give you a +1. Okay, so 1, 0, 3, 1 is the new first row. Okay, all right, keep going. Long, long process. Okay, we are still in the second column. Okay, we have our 1 on our principal diagonal. We've zeroed out above, but now we need to zero out below. Okay, so we need to change this -2 to a 0. Okay, again, zeros are best gotten by the third row operation. Okay, we are making a change to row 3 here. Okay, to make that change, we're going to add something to row 3. Okay, well, what do you add? A multiple of another row. Okay, so again, which row do we multiply by? Well, look at your column. Okay, find the 1 in that column. Okay, that 1 is in the second row. So we're multiplying by the second row. Okay, what are you going to multiply the second row by? Well, you're trying to cancel a -2. So you're going to multiply by a +2. Okay, if you take row 2 and multiply by 2, okay, that'll be 2 times 1 will be +2. You add it back to -2, you will get your 0. Okay, so in our next matrix, row 3 is changing. Okay, so that means rows 1 and 2 stay put. Nothing happens to them. Okay, so I'm just going to rewrite them. Okay, so there we go. Okay, now I'm going to go out to the side and do my work. Highly recommend doing that. Okay, I am going to take a 2 and multiply it through row 2. Okay, so remember row 2 is 0, 1, -2, -2. Okay, we're going to multiply everything in row 2 by +2. That is going to give us 0, 2, -4, -4. Okay, we are going to add this back to the current row 3. Okay, so that's 0, -2, 9, 9. Okay, so if we add, we're going to get 0, 0. -4 plus 9 is +5. -4 plus 5, or sorry, -4 plus 9 is +5. Okay, so that is going to be your new row 3. So 0, 0, 5, 5. Okay, so we are done with columns 1 and 2. Okay, Look at this second column that we've been working on. We've got the 1 on the principal diagonal. We zeroed out above and below. Time to move on to column number 3. Okay. Every time you start a column, your first goal is to put the 1 on the principal diagonal. Okay. Again, here are the principal diagonal elements. Okay. Those are the guys that have the same row number as column number. So in this column, 5 is your principal diagonal element. You need to change that to a 1, okay? So the best thing you can do here, okay, is the second row operation, where you take, you multiply or divide everything in the row by a non-zero number, okay? Everything in row 3 is divisible by 5, okay? So my next operation is going to be to take everything in row 3, we are going to divide it by 5, and that's going to replace row 3. Okay, so we're just dividing the entire row by 5. Okay, so that means that rows 1 and 2 will stay the same. So I'm just going to rewrite these. Okay, and now, you can either do this work in your head or you can write it out if you need to. If you take row 3, which is 0, 0, 5, 5, you're going to divide everything by 5. Okay, that'll give you the new third row. 0 divided by 5 is 0. 0 divided by 5 is 0. 5 divided by 5 is 1. 5 divided by 5 is 1. Okay, so that is your new matrix. Okay, all right. So still have a couple more row operations to do. All right, so still working in the third column. We've secured the 1 on the main diagonal. This one is going to help us zero these two elements out. Okay. So we need to zero out the rest of the column. I just go from top to bottom. So I'm going to try to zero out this 3 now. Okay. All right. So again, best thing you can do is the third row operation here. Okay. So let's see here. What we're going to do is we are going to, and I'm going to need some more paper here. We are going to, let's see here. We are going to replace row 1. Okay. So to replace row 1, how are we going to do that with that third row operation? Well, we are going to have to add something to row 1. Okay, what do you add? A multiple of another row. Okay, which row gets multiplied by something? Well, remember, you're working in the third column. You've secured this 1 on the principal diagonal. You use this 1 to zero out the rest of the column. This 1 is in the third row. Okay, so we're going to multiply by row 3 and then add it back to row 1. What do we multiply row 3 by? Well, we are trying to cancel a positive 3, so we're going to multiply by a negative 3. Okay, so this is going to be our row operation here. Okay, we're going to do negative 3 times row 3. Okay, that would put a negative 3 right here. Okay, and then if you add it back to row 1, negative 3 plus positive 3 will give you the 0. Okay. All right, so in your next step, you are replacing row 1. Okay, so that means row 2 will stay put. So will row 3. Okay, and now we'll do the work to get the new row 1. Okay, so let's go out to the side. We are going to do negative 3 times row 3. Okay, row 3 is 0, 0, 1, 1. Okay, so multiply everything by negative 3. So we'll get 0, 0, negative 3, negative 3. We're going to add this result back to the first row. The first row is 1, 0, 3, 1. Okay, and this is going to give us, if we add 1, 0, 0, negative 2. Okay, so this is going to become your new first row. Okay, so that's your latest matrix. Okay, all right, so we are almost done. We are almost to our goal matrix. Look at your goal matrix. Okay, we are almost there. Okay, the only thing left to do, still in the third column, we need to zero out this guy. Okay, and then we should end up with identity on the left of the vertical bar. Okay, all right, so to get your 0 there, okay, again, third row operation, okay, we are going to want to change the second row. Okay, so we need to add something to the second row. okay? And what do we add? A multiple of another row, okay? Again, we're in the third column. We are using this one on the main diagonal to help us, okay? This one is located in row 3, okay? So we need to multiply row 3 by something. What do you multiply by? Well, I am trying to get rid of a -2, okay? A +2 is going to be what cancels that, okay? So this is going to be your last row operation. 2 times row 3 plus row 2 becomes row 2, okay? So if you do 2 times row 3, okay, 2 times row 3, we'll put a +2 right here. You add it back to row 2, or add it back to -2, you will get your 0, okay? All right, so let's do that. Okay, so in your last row operation here, you're changing row 2. Okay, so that means row 1 and row 3 will stay put. So write down row 1 as it is because it's not changing. And then write down row 3. It's not changing. Okay, let's figure out the new row 2. Okay, so I'm going to go out to the side. I'm going to do 2 times row 3. So everything in row 3 gets multiplied by 2. Okay, add it back to row 2. Row 2 is 0, 1, -2, -2. Okay, add. Okay, 0 plus 0, 0 plus 1, 2 plus -2, 2 plus -2. Okay, there is your new second row. 0, 1, 0, 0. Okay, we are done. Okay, this is your identity matrix right here. You have 1s on the main diagonal, 0s everywhere else. Okay, so you can stop doing row operations, and now it's time to interpret the solution. Okay, so remember what we talked about when we did smaller systems. Okay, you can easily turn this back into a system of equations. Okay, this last matrix, this column represents the numbers in front of x. The second column represents numbers in front of y. The third column represents numbers in front of z. Okay, and then you've got your equal sign and the numbers on the other side. Okay, so if you translated this back into a system of equations, okay, you get from the first row 1 times x plus 0 times y plus 0 times z equals -2. Okay, if you simplify that, okay, this is 0, this is 0, and you get that x equals -2. Okay. If you did the same thing to the second row, translate it back. 0 times x plus 1 times y plus 0 times z is going to give you 0. Okay, so again, 0 times x goes away, 0 times z goes away. We end up with y equals 0. And then the last one, okay, the third row, 0 times x plus 0 times y plus 1 times z equals 1. Okay, 0 times x is 0, 0 times y is 0. You are left with z equals 1. Okay, so that's it. Okay, this is one particular solution. Okay, in order for to have a solution for this system, there is a solution. There's exactly one solution. Okay, so x has to be -2, y has to be 0, z has to be 1. Okay, if you plug in those variable assignments into all 3 equations, okay, you will get true statements. Okay, so to write down your solution, okay, I'll put it over here. Okay, well, I'll put it over here. I'll put it at the end of here. Okay, to write down your solution, okay, you can either do what we just did, okay, where you say, okay, specifically x has to be -2, y has to be 0, z has to be 1, okay, or you can write it as an ordered triple, okay, and as an ordered triple, you put the x coordinate, then the y coordinate, then the z coordinate, okay, so you can also write it as -2, 0, 1, like that, okay, and then it's understood this is the x, this is the y, this is the z, okay, all right, but again, remember what this means, okay, this variable assignment, or these assignments to x, y, and z, okay, if you went back to your original equation, okay, your original system of equations, if you went to each equation, all three of them, and you plug in x equals -2, y equals 0, z equals 1, okay, you are going to get a true statement for all three, okay? So this is how you do the Gauss-Jordan elimination. It is obviously a very lengthy process, okay? You are always going to be working towards your goal matrix, okay, using your 3-row operations, okay? And that is what you do, okay? You work towards that goal matrix using the 3-row operations until you get to that goal, okay? If you can't get to your goal, and we will see that in a couple of examples, that means it's either going to be no solution or infinitely many, okay? So let's